You've seen it your entire life, in textbooks, on posters, in every "space is amazing" photo compilation ever made. That planet with the rings. You probably thought it was beautiful. You were right. You just didn't know what you were actually looking at. Saturn is the most visually deceiving object in the solar system. Nothing else looks like it. Nothing else has ever looked like it. When Galileo first observed it in 1610, he didn't know what the rings were. He thought Saturn had two large companions on either side. 2 years later, he looked again, and they were gone. The rings had tilted edge on and became nearly invisible. He wrote, "Has Saturn swallowed his children?" He was confused, disturbed. He never figured it out. It took another 45 years and a better telescope for Christian Huygens to correctly identify them as rings. Humanity stared at Saturn for nearly half a century and couldn't understand what it was showing us. That should tell you something. Let's start with the rings, because everyone thinks they know what they are. They don't. The rings look solid from Earth. They look like flat, smooth disks of material orbiting a planet. Stable, serene, almost architectural. Here's what they actually are. Billions of individual pieces. Ice, rock, dust. Some particles the size of a grain of sand, some the size of a house, a few as large as mountains. All of them orbiting Saturn at speeds between 15,000 and 22,000 kilometers per hour, and they have been colliding with each other continuously for hundreds of millions of years. What looks like a peaceful ring from Earth is, up close, a permanent demolition derby happening at orbital velocity. The rings are not quiet. They are not still. They are a system in constant, violent, microscopic chaos, held in shape only because Saturn's gravity won't let them escape and won't let them collapse. Saturn is holding billions of pieces of debris in permanent suspension between destruction and freedom, and it looks gorgeous doing it. Now here's the detail most people never hear. The rings are disappearing. Not eventually, not in some abstract cosmological future. Now, actively, measurably. NASA estimates Saturn's gravity and magnetic field are pulling ring material down into the planet's atmosphere. Saturn is losing between 10,000 and 100,000 kilograms of ring material every single second. At that rate, the rings could be completely gone in 100 million years. That sounds like a long time, until you consider that dinosaurs went extinct 66 million years ago. The rings might not outlast the next dominant species on this planet. And here's what makes it stranger. The rings themselves might be young. Current models suggest they formed somewhere between 10 million and 100 million years ago, which means the rings didn't exist when dinosaurs were alive. The most iconic feature in the solar system is temporary. We exist at the exact window in cosmic time when Saturn looks the way it does. Before us, no rings. After us, no rings. Right now, for this brief moment in the 4.5 billion year history of the solar system, the rings are here, and we got to see them. Like Jupiter, Saturn is a gas giant. No surface, no ground. You cannot land on Saturn. There is nowhere to land. But Saturn is different from Jupiter in one critical way. Saturn is the least dense planet in the solar system. Its average density is lower than water. Saturn would float. A planet 95 times the mass of Earth. 764 Earths could fit inside it, and it would float. That sounds almost funny until you think about what it means. Saturn is mostly hydrogen and helium, the two lightest elements in the universe, compressed into a sphere large enough to swallow almost 1,000 Earths, but still not dense enough to sink. It is simultaneously enormous and almost nothing. The upper atmosphere of Saturn is cold, around -178 degrees Celsius. Wind speeds at the cloud tops reach 1,800 kilometers per hour, the fastest winds on any planet in the solar system. Faster than Jupiter. Faster than anything on Earth by a factor of 5. Earth's most powerful hurricanes reach around 300 kilometers per hour. Saturn's equatorial winds are 6 times that. Sustained, permanent, not a storm, the baseline. And like Jupiter, those winds don't stay near the surface. They penetrate deep into the interior, thousands of kilometers down, driving weather systems we don't fully understand. But Saturn has something Jupiter doesn't. In 2010, a storm began forming in Saturn's northern hemisphere. Within weeks, it had grown into a convective system that circled the entire planet. It was generating lightning at a rate of 10 strikes per second. The storm lasted 200 days before something unexpected happened. Its head caught up with its own tail. The storm consumed itself. That doesn't happen on Earth. It doesn't happen on Jupiter. It is something Saturn does, on roughly a 30-year cycle, that we still cannot fully model or predict. At a certain depth inside Saturn, pressure builds until hydrogen becomes metallic. Electrons stripped from atoms, flowing freely, generating a magnetic field. That field has one property unique in the entire solar system, and that physicists still cannot explain. It is almost perfectly aligned with Saturn's rotation axis. Every other planet, Earth, Jupiter, Uranus, Neptune, has a magnetic field tilted relative to its spin axis. Earth's magnetic north is offset from its geographic north by about 11 degrees. Jupiter's is offset by 10 degrees. Saturn's offset is less than 1 degree. This should not be possible. The models we use to explain how planets generate magnetic fields predict that a perfectly aligned field would be unstable. It should drift. It should tilt. Every simulation says it must. Saturn's magnetic field doesn't care. It has been aligned within 1 degree of perfect for as long as we've been able to measure it. We don't know why. Saturn has 146 confirmed moons, more than any other planet in the solar system. Titan is the second largest moon in the solar system, larger than Mercury. It has a dense nitrogen atmosphere, thicker than Earth's. It has weather. It has seasons. It has rivers, lakes, and seas, not of water, but of liquid methane and ethane, the same stuff that fuels cars. On Titan, it rains gasoline. The surface temperature is -179 degrees Celsius. If you stood on Titan without protection, you would freeze within seconds. But if you could survive the cold, you could technically breathe the atmosphere. The nitrogen content is close enough to Earth's that the pressure wouldn't immediately kill you. You'd die of cold and methane toxicity. But for a brief moment, you'd be standing on another world with an open sky above you, under orange clouds, beside a methane lake, on a moon 4 times further from the sun than Earth. No other place in the solar system offers that. Then there's Enceladus, only 500 kilometers across. In 2005, the Cassini spacecraft flew past and detected something nobody expected. Geysers. From the south pole of this tiny frozen moon, enormous plumes of water vapor were erupting into space, containing ice, salts, organic molecules, and silica particles that could only form at temperatures above 90 degrees Celsius. Beneath the ice, a global liquid water ocean in contact with a rocky seafloor being heated by hydrothermal vents. On Earth, hydrothermal vents at the bottom of the ocean are some of the most biologically rich environments on the planet. Life clusters around them in complete darkness, driven entirely by chemical energy. Enceladus has the same setup: liquid water, chemical energy, organic molecules, the ingredients. Cassini flew through those geysers. We have already sampled the interior ocean of another world without even landing. Whether life exists in Enceladus's ocean is not a rhetorical question. Scientists treat it as a genuine open question. Not, could life exist somewhere out there in the universe, but does life exist right now in our solar system, 1.2 billion kilometers from where you're sitting? Saturn has been doing all of this. The vanishing rings, the self-consuming storms, the impossible magnetic field, the moon where it rains gasoline, the moon venting its ocean into space, for 4.5 billion years. Before the first fish, before the first tree, before us. That steady golden point in the night sky, pulling its own rings apart, spinning storms that consume themselves, hiding an ocean that might already hold the answer to the oldest question we've ever asked. All while looking from a billion kilometers away, like the most peaceful thing you've ever seen. Saturn doesn't care that you find it beautiful. It never did. It was doing all of this long before there were eyes to see it. And it will keep doing it long after ours are gone.